NASA's Psyche mission is almost ready for its moment in the Sun, a 1.5 billion mile solar-powered journey to a mysterious, metal-rich asteroid of the same name. Twin solar arrays have been attached to the spacecraft body, unfolded lengthwise and then restowed. This test brings the craft that much closer to completion before its August launch. At 800 square feet, the 5-panel cross-shaped solar arrays are the largest ever installed at Jet Propulsion Laboratory, which has built many spacecraft over the decades. When the arrays fully deploy in flight, the spacecraft will be about the size of a single tennis court. After a 3.5-year solar-powered cruise, the craft will arrive in 2026 at the asteroid Psyche, which is 173 miles at its widest point and thought to be unusually rich in metal. The spacecraft will spend nearly 2 years making increasingly close orbits of the asteroid to study it. Venturing to the asteroid belt between Mars and Jupiter, far from the Sun, presents challenges for this mission, which adapted standard Earth orbit and commercial satellite technology for use in the cold and dark of deep space. Near Earth, the solar arrays generate 21 kilowatts, enough electricity to power 3 or 4 average homes. But at Psyche, they'll produce only about 2 kilowatts, sufficient for little more than a hair dryer. The underlying technology isn't much different from solar panels installed on a home, but Psyche's is hyper-efficient, lightweight, radiation-resistant, and able to provide more power with less sunlight. After the successful installation and deployment of 3 center panels inside a clean room at GPL, Psyche's arrays were folded back against the chassis and stowed for additional spacecraft testing. Later this spring, the arrays will be reunited with the spacecraft at NASA's Kennedy Space Center in Florida and stowed for launch from Cape Canaveral. About an hour after launch, the arrays will be deployed and latch into place in a process that will take 7.5 minutes per wing. They will then provide all the power for the journey to the asteroid Psyche, as well as the power needed to operate the science instruments. A magnetometer to measure any magnetic field the asteroid may have, imagers to photograph and map its surface, and spectrometers to reveal the composition of that surface. The arrays also power the deep space optical communication technology demonstration that will test high data rate laser communications. What those instruments relate to scientists will help them better understand the mysterious asteroid. One possible explanation for Psyche's unusually high metal content is that it formed early in our solar system's history, either as remnant core material from a planetesimal, one of the building blocks of rocky planets, or as primordial materials that never melted. This mission aims to find out and to help answer fundamental questions about Earth's own metal core and the formation of our solar system.